Podemos iniciar?
Okay, shall we begin? Good morning, everyone. And first, I would like to thank the IOC, which is our vice president, Elsie from El Salvador, and Maura from the Dominican Republic, which are the two people that compose the directive board for the Americas and have as attributions to work to share the knowledge of the subject matters for professional training. For this, they organize the webinars that we hold monthly today and 29th of April and so on. And also, they collect and organize articles for professional education, which is in the site of Training America. Next slide, please. Okay, just to remind you, for those that are coming in today, we have 27 member states that share this kind of education in the Americas. Well, it is very important that the questions be made at the end of the live meeting, so you can write down your questions in the chat, and you can ask in Spanish or English, and we will translate the questions to the speaker today, because we have also the simultaneous interpretation. So where you see interpretation, you can choose between Spanish. We have Georgia for Spanish, and for English, we have Alex that will translate from Portuguese into English. We will have a duration, and please next slide. The duration is of 1 hour, and we will have questions answered in 10 minutes. If for any reason the number of questions exceeds this time, we will answer the questions in writing from Professor José Ricardo. He will answer these questions and answer the questions that will be sent to you through email. It's very important for you to maintain the vision of World Skill Americas. We identified the need from most that we think about in new technologies for new professions. So today we will have Professor Ricardo, and on the 29th of April, we will have Industry 4.0 and the professional competencies to defend this technology. So for the webinar today, we invite Professor José Ricardo, which is the coordinator of José Mariano Ferraz College, and I can say that I have known him for 35 to 40 years. He is a dedicated individual and someone who has his whole focus and professionalism dedicated to professional education in several levels, and you will be able to see clearly through his presentation, which is for a technical level, technologist, and engineering level. So the theme today will be new technologies, new professions, with the focus in IoT, or Internet of Things. So I invite as a speaker, Professor José Ricardo da Silva. You have the floor. So, good morning, everyone, and welcome to this live webinar. I would like to thank Professor Spada for the invitation and World Skills for the opportunity. And the theme that we're going to talk about today is new technologies, new professions, which is a natural part of the flow of technological evolution. And the focus will be Internet of Things. Mm, So, as Professor Spada mentioned, I am the coordinator of the Senai Technology College, Mariano Ferraz, located in the state of São Paulo in Brazil. And my purpose today is to present to you the way in which we are dealing with this subject in our college and present as an additional option uh, turning to the professional training. So going back, I'm the coordinator of Sinai Technology College, and the purpose is to present another point of view of how to deal with these technologies and how to develop courses that can enable professionals in the correct manner. So I'm going to start speaking about the current scenario, where everything begins with the craftsman that created the manufacturer, where everything was done by hand until we reached the first industrial revolution. And then we had as enabling technologies, mechanics, and steam power. And what was handmade was now being made by machines. In the second industrial revolution, the change was in the enabling technologies, electricity, methods and processes of production, and it started the phase that we call automation of manufacture. And what was done when machines is now done in automatic machines. In the third industrial revolution, the enabling technology was the microelectronics and robotics. And what we were doing in automatic manufacturers, machines, is now being done by automatic machines with smart functions. And lastly, the fourth industrial revolution, which the enabling technology is the Internet of Things. It is the condition of putting all the devices in a network, and the access to these technologies through the internet will allow us to be able to develop the intelligent manufacturing, where the interactive and intelligent autonomous machinery will be responsible for the production. The great difference that we have, what is new, is that in the first three industrial revolutions, we would work in the offline mode. And the fourth revolution brought in the online, where we will have everything linked to the internet, and thus we will be able to access with mobile devices and know everything that is going on in real time. Now I'm going to change a little bit the subject to say which are the enabling technologies of Internet of Things. So for the Internet of Things to occur, first I have to establish what is things. So things are devices, the physical elements, the concrete elements, and they are classified as machinery, equipment, devices, persons, animals, plants, buildings, vehicles. So we can consider that everything is a thing. And the main purpose here of Internet of Things is that together they will be able to interfere in the environments where we are working in. So the verticals would be, I can have Internet of Things in agriculture, in cities, in the industry, in health, And in all of these environments, we will have the same structure, which is the one that I'm going to show you next. And this structure can be can change due to the characteristics, which is transmission rate, density, latency, but I'll go into further detail in the following slides. So the first enabling technology of Internet of Things are the embedded systems. The embedded systems can be electronics, which are hardware, the electronic motherboards that will have elements and systems that will be able, through softwares, so I'll have a microchip or an electronic motherboard, a processor, where I can put in softwares with components that allow for communication. So I'm going to put all the data that I'm collecting from sensors, for example, connected to the internet. And a level of security. And this level of security is, I'm putting here some items, for example, an R12, which is a Brazilian norm that has as focus the protection against personal injury, so to protect workers so that they don't suffer any kind of accidents in their workplace when they are operating a device or machinery. So in our case, we consider both security focused on equipment and hardware, as well as security in data, which would be cybersecurity. Following, we will have the layer where we have the filters, which is edge computer, because the data that we send to the cloud will be stored according to the volume. I will pay for that volume. So there is a cost for the cloud. So instead of putting all the data on cloud, I'm going to filter, organize this data, and transfer them to the cloud only what is necessary and important. After the data are in the cloud, then we will start working with, firstly, network infrastructure, which would be what will make the transition from the equipment to the cloud. So the first enabling technology of infrastructure is IPv6. So IP, which is the internet address or internet protocol, this system refers to the address of the devices. So this next layer, we have IPv6 and V stands for version. So in the system IPv4, which is a prior system, we had 4 million addresses in the internet. And these addresses are attributed in a dynamic way. In other words, when I enter the internet, I receive an IPv4, and when I exit, this address is transferred to someone that is going into the internet at that moment. However, for the Internet of Things, it is necessary that the IP be fixed, because when I work with IPv4, the address of the computer, for example, within the network changes constantly. And when I work with the Internet of Things, the things will have to have a fixed address so that I can find them with precision and instantly. Therefore, IPv6 was created, which is a structure that has 340 undecillion addresses. So we left 4 billions, 4 with 9 zeros, to 340 plus 36 zeros. This is enough to keep the system going for many years until we use all of these addresses using the equipment connected to the internet. The next enabling technology for networks is 5G. So 5G brings some characteristics that are very important, and the first would be latency. So latency, as appears up here, a check mark, for example, when I send a WhatsApp message. So when I send it, there is a check mark, and when the person receives, I have a signal that confirms that the person received that message. So this would be a latency, the time in which the signal reaches the device that I want to communicate, and I have a feedback that the information was delivered. So latency, when we used to work with 4G, this time varied between 60 to 80 milliseconds. In 5G, the in Ericsson, for example, is 1 millisecond of latency. Another characteristic that we consider important is the density. So density would be the amount of devices that can be served by square kilometers. So 4G supports 66,000 devices per square kilometer. 5G supports 1 million devices per square kilometers. So this is another assurance that I will be able to enable this technology of Internet of Things. I can have a company or an agriculture company within a space of 1 square kilometer to serve this whole density of devices. Another advantage would be the rate of data transmission. So 4G works very well for megabits per second, the rate of transmission. 5G is gigabytes. And people are already thinking about 6Gs, which will be terabytes. So these three characteristics are extremely important to enable the Internet of Things. Another enabling technology would be the way in which Wi-Fi will service the devices. So the normal Wi-Fi will have a band, and in that environment, people, as they use the Wi-Fi, the rate of data transmission is going to be distributed amongst the users. But this model can't be used in industry. I can't have a machine working when I turn on another one, the performance starts to drop. The Wi-Fi 6, what it does is each equipment that enters has an exclusive channel for it, and then this channel, exclusive channel, enables the normal performance of each equipment. And the last characteristic here would be the web semantics. So the web semantics, the meaning of what is in transit there. So for example, I enter Google and I place a question. In the sequence, there is an answer a page that opens. But in some cases, we will see at the footnote of the page, and we can have over 10,000 pages with that answer. So that means that that didn't answer my question. Google gave me a range of answers. So I have to continue searching for I'm looking for. Web semantics tries to, as from the moment that you use artificial intelligence, they identify my profile, and when I ask a question, it is going to answer exactly what I asked. And when we deal with things or equipment, the more precise the information is, the greater the efficiency of the system. After going through this phase of communication and network, these data are going to be stored on the cloud, which are data centers that are going to store these data. And due to being in a network, it will allow for mobility. If I have a cell phone and I am somewhere that has access to the internet, then I will be able to have mobility as long as I have connectivity. So the cloud allows exactly that, that from anywhere we are able to communicate and to see what is being done, for example, in an environment where a sensor is collecting data. And there is also the possibility of cloud computing. So, cloud computing would be instead of having the programs in my device is just only a communications interface, and the programs will reside on the cloud, allowing me to access them without having an equipment with its memory full. After the data is in the cloud, we are going to use big data techniques. So the big data will be algorithms and softwares that will see what is in the cloud and mine these data to identify the data that are correlated and to begin to analyze and transform this data into information to allow decision making, for example. And the last layer, which is artificial intelligence. So artificial intelligence, it is going to be used to learn with machine learning, for example, which is a part of artificial intelligence. So it's going to learn with this data and information that are available within the cloud and have been dealt with by big data. And this data will be turned into knowledge for decision making. So and usually we start with predictions. So a prediction is when I am able to predict what is going to occur. For example, if I have equipment in maintenance, for example, in my production line, and I start to forecast when the failures are going to start happening. So this is possible with the collection of data of temperature, vibration that can signal me that the equipment is going to break down. As I am able to have this with more precision, I pass on to the second phase, which would be prescription. Prescription is when the system is going to tell me how I have to use this resource so that instead of it breaking down next month, it is only going to break down in 6 months because the system already knows how the evolution of the problem works and is able to prescribe what I have to do so that it doesn't break down before time. And lastly is the decision making, which is the main purpose of these systems. Besides that, we will have a security layer which is transversal, which will be present in all of these layers and will be accordingly to the risk that I may have in my system, the number of layers that will be necessary in terms of cybersecurity. And lastly, the user layer. So the user layer is divided into two types. We have the UI, which is the user interface for the user. Interface can be a cell phone, tablet, your computer, Alexa. So this is the way that the system communicates with the human being. And we also have the user experience, UX, which would be for enable or to facilitate this interaction between humans and equipment. For example, we have a logic of analysis where, for example, a person is working in a computer and is having difficulty using a certain software. A logic would be to look at this and say, this person has difficulty to interact with the equipment or the system or the software, for example. The other logic would be the contrary, which would be the user experience is that the software has a difficulty to interact with the human being. So from small actions such as we become older, for example, our memory starts to fade. So I can be completing an operation in the cell phone, and when I get to the end screen, I get distracted, and going back to the screen, it says to finalize the action, but I don't remember what I was supposed to finalize. So finalize what? So only the fact that putting finalize payment, finalize registration, this will facilitate my experience with that application because I went back and reading that information, I was able to remember what I was doing. So we are considering here when we are undertaking our studies that the Internet of Things entails all these variables because it is a system. So the ideal is that I am able to understand the system as a whole, so I am able to make decisions and create systems that are more autonomous, because this is the main purpose of these new technologies, which is to create autonomous systems. So systems that have self-diagnostics, self-setup, self-programmable, self-managed, so everything is self-done. We are always talking about a scale of 0 to 100%. So there will be situations in which these things that we are talking about, these layers, will have a relative importance, such as 30%, and there will be applications in which I will have to use 100% cybersecurity due to data volume and other things. So the main purpose of these technologies that are arising is to create autonomous systems. And what we see is that in each layer, it will be necessary to have specialists. We will have professions that will work generically, that will view the system as a whole, and we will have the exclusive professions for each one of these layers because they entail a lot of complexity. So, to sum up what we have been talking about, the purpose of IoT and these enabling technologies is to be able to have autonomous systems. And to be able to have that, I always start with things. What are the things that I want to turn into autonomous? I will have embedded system, electronic embedded systems. Then I connect this to networks. I put a filter to pass on only the relevant information to the cloud. And following that, I use big data algorithms. And finally, the neural networks and artificial intelligence for decision making, without forgetting the security layer and the user layer. So this is the point of view that we are using in our college. Now I'm going to change the subject a little bit. So let us talk about vocational training or professional education. So when I talk about professional education or vocational training, at first, today we know that the volume of information is huge because we are going through times in the world of innovation. So, since innovation happens in a very rapidly, it is complicated for us to focus in a certain technology. So, to create the courses of professional education, we are trying to focus on the large functions, the main functions. So the main functions in the case of Internet of Things, but not only IoT, but also in other areas, is installation, commissioning, setup, programming, maintenance, design, and doing the management. So even if we, for example, go to 6G, I'm still going to have to install new devices or antennas. So we try to focus always in the main functions which are permanent. So if I know that I have to make an installation, I can modify the techniques for this installations and also the technologies. So I have to know the process today and the technologies as they change. I have to update myself so I'm able to continue with my profession as an installer, for example. I put here 3 columns that are the same because if I consider that this would be the Internet of Things, the main functions of Internet of Things, that I put 3 columns because we have professionals, 3 kinds of professionals: the technicians, the technologist, and the engineer. If they are going to study Internet of Things, they have to study this as well. The technologist as well, and as well as the engineer, but it's not the same thing exactly. What changes is the profile of each professional. So the technician is an operational professional, the technologist is a technical professional, and the engineer is a strategic professional. Because since we know, let me put this up here. Each professional will have its own proficiency. So the technician has to have proficiency in techniques. He has to know the installation techniques, programming techniques, maintenance techniques. That's why he is a technician. He masters the execution techniques. The technologist is a tactical professional. In other words, he masters the technology. And the engineer is a strategic professional. He has to have the systemic view of the process because when he makes a decision, we can say that the division of chores between or tasks between these professionals are the engineer establishes what is going to be made, the technologist how it's going to be made, and the technician is the one who is going to make it. So this would be the division of roles. The engineer has to have a systemic vision because when he makes a decision, he has to assess the impacts, the economical, social, legal, environmental, technological impacts. And so, besides knowing his area, he has to know how this area is going to interact with the other variables in the system. Another important characteristic that we included today in all courses is innovation. So innovation today is considered to be a skill required by the market. So every professional has to have this skill. And for that, the college must prepare the technician for an incremental innovation, which are the improvements, the small improvements that will enhance functionality, performance of the process. The technologist has to be prepared by the college to make technological innovations. So, for example, I had a cell phone only to make calls, and then the micro camera arises. So when we put the micro camera in the cell phone, it is now used besides calls to take pictures. So this is a technological innovation. When I insert a technology in a product or an existing service, to be able to have new functionalities, new performance, and so on. And the engineer, the college has to prepare him for radical innovation or disruptive innovation, which is when we have a change of concept. For example, we were recording data in CDs and DVDs, and all of a sudden we have the drive stick, which is a totally different concept from the prior technology. Another consideration that we make is the characteristics of the workplace. So the technician acts in the tangible part, in the concrete part of the process of the product. And the engineer is going to work with the intangible, which is the design, planning. And for this, we also use a scale of mathematics and physics to know where that content or function must be placed. For example, if I have to develop algorithms for a mathematical modeling, I won't be able to put this function to a technician because he doesn't have yet the necessary knowledge to execute this. And so the scale of mathematics and physics helps us to distribute the content for each one of the courses. So this line that we are showing now for us is the profile of the technician. So he has to master the operational side of things and know a little bit of tactics and strategy to be able to communicate with the other levels. The engineer on his side has this profile, so he has to master the strategic part. He has to know tactics and operational. This is always showing how he is going to end up the course. And as he works, his experience is going to change, so he will master all these three columns. So the fact that the courses give little practice to the engineer, sometimes it occurs that we listen in the factory store, the operators saying, well, did you know that the engineer doesn't even know how to turn this machine? But that's not his function. So it's the same thing to have the engineers saying that the operator doesn't know how to do calculus, for example. So each one is within his environment using their skills. And the technologist, we understand that this is his profile, since he is a specialist in technology, is to know how to do the transition from tangible to intangible. So from the time that he receives a project, he will see within the technologies that serve that project how he will adequate the relationship cost benefits. Sometimes he has a lower budget. We can't use this technology. Let's use this other technology. And we also have postgraduate courses. And the post-graduation, we work with this profile. So we make a deep dive in this strategic aspect without letting the operational aside. So if the school already has the college already has laboratories, the graduation schools have a practical or a practice part to validate some concepts that they are observing on their daily routines. Now let us change subjects a little bit. What is the methodology that we are using to develop these courses? Well, as any subject that we can talk today is a world of information, is a lot of information, and the courses have a limited time of duration. So what we are doing is the following. I'm going to use as an example postgraduate of Internet of Things. Until 2019, we had this model. I divided the content of 360 hours of the course into 12 models of 30 hours. And then we changed for this to this model. So from 2019 to now, we work with 3 projects of 120 hours each. Because in the prior model, for example, I would have to have 30 hours of big data. That is not enough. So when it is a project, I'll have the application of big data, for example, and we will develop the content so that he can perform that specific task. So we developed it in this way. We have a timeline of the course here. And here I have the 3 projects that will be delivered. So in our case, the first semester, we work with collection, transmission, and data storage. In the second semester, we take the data that were in the cloud. We applied big data, machine learning, and artificial intelligence techniques. And in the third semester, the student now, because we have students from several different areas, from several different professions, so we allow them to have some kind of a project in their area applying what has been learned in the first 2 semesters with the support of the professors. And to close the course, they have to hand in an article about the area that we are studying and which has been developed by them. So this is the way we work. As when I already know what I'm going to deliver, the professor is going to help to open the content sufficiently for him to solve this problem. Another thing that we saw as well is that we have students with different levels of knowledge in this area. And this makes for some students to be able to deliver and other students end way before the end of the semester. So what we do is we group the students by the level of knowledge they have. So I have the students that have more knowledge and the other students that have less knowledge. The ones that have less knowledge, the professor is going to give more attention to them so that they are able to deliver these projects. And the studies that have more knowledge, they're going to end the task beforehand. For the normal student, what we're going to do is the professor is going to be a facilitator for him to reach this stage. He's going to be a facilitator, and from then on, we'll make things a little bit more difficult. So the student which has more skills or knowledge will finish first, but we place then more difficulties, such as the solution that you used counts 10, but you have a budget of 8, for example. So he has to rethink about solution to fit it to the budget. In case he finishes before, I can put the security requirements are such and such, so he has to rethink again. And this ensures that the student has enough stimuli to continue with his studies and his development. And this is repeated in the other modules as well. So the idea is that we found so that students don't get frustrated. If I only work with content, some students have different expectations, and sometimes they drop the course, and if they're uninterested. And in this model, we saw that all the students are very well engaged. There are very few dropouts. So we are working in this way when we are dealing with these new technologies that change very rapidly. We have some laboratories. This laboratory, we work with electronics in these desks and also the application. In this case, they are using the notebook or the laptop, a Raspberry, a tablet, an IP camera, another camera here used to Arduino and other kinds of applications. So according to the application that we're going to develop, there are some tasks that have to be made that involve hardware programming, so that the program that I'm going to use in the hardware will yield the expected result. This is another laboratory for building automation where we have the part of fire alarm. Here we have alarms, command, uh, lock, locks through and we have other systems for biometry and facial recognition. And here we have the sensors, CFTB. So we do a little bit of application in building automation. Always for 20 students, these environments. And we also have a lab here for structured cabling where we work with the networks. And this, we believe that there was a value of $200,000 to be able to assemble the three laboratories, but we can assemble this with a lower budget using, for example, the resources that we mentioned of Arduino and Raspberry, so that at least the concepts are able to be passed on for us to be updated. But if we have the conditions, the ideal is to have the most technology available, possibly available. Um, this course began in 2017. Until today, all the classes that have been entering face a new course due to the change in technology, which is constant. And we always work with 20 students per room. And finalizing, a suggestion that we have been making and that we use in our college is that if possible, we prepare ourselves so that the environments be used the morning, afternoon, and night. We use this in the three periods and also on Saturdays. And we try to work with all the levels of education. So the technician, technologist, and engineer in post graduation. Then we have always started with post graduation because the level of students that we receive, they are already professionals, which helps us to explore further these resources. And as they master these skills, we pass these subjects to the other levels, but with a larger range. And I have a group that is going to be updated and the other levels are going to receive this information and incorporated it in the course for their formation. So this is what I had to present to you. I am open now to a Q&A session. And also we have here, besides these regular courses, we have continued and initial formation, which are short courses, specific courses. For example, there is a professional that already works in electronics, but he wants to learn about installation of access points or some kind of new devices of the new technologies that are arriving. So he can come to Senai to have a specific course with a duration of 20 or 40 hours up to the limit of 160 hours, which are the courses that we offer. So thank you very much, and let me pass the floor back to the uh, presenters. Professor Ricardo, congratulations for your explanation, both the technology to change the educational structure. I know very much about your work, and I would like to make the following suggestion. If any institution would like to know more about this project, you can plan a visit, and I'm sure that spending 1 or 2 days with Professor Ricardo and his team, I'm sure that it will be an exchange of experience at a high level. So I would like to ask the colleagues, Marino and Gustavo, do we have any questions in the chat? Otherwise, we can close this session. Yes, we have 2 questions, Professor. Okay, please, can you pass Marino to Professor Ricardo? The first question talks about the uh, languages for big data, the Python, Java, which are 2 types that are used, and they're asking which are the main languages used. Luis Frias made the question. He didn't mention the country he's in. Ricardo, if you can check this out, please. So here we have been using more the Python and MTTT protocol, which are the most used, because the main purpose here is that the student is able to have this, and in case he wants to specialize. Sorry, there's a lot of interference. I cannot hear the speaker. Someone has their microphone open. Okay, here we go. So we use these languages, Python and MTTT protocol, so that the student is able to understand the functionality. And Senai has other specific schools for cybersecurity, cloud development. So we have other schools where we can send the student in case he wants to make a deeper dive into these issues. But our courses are basically the ones that have been exposed. Any more questions? Yes, Mr. David Cano is asking if all the courses that are structured in Sinai are structured in the same way. Okay, so what we have been doing is to structure the courses in post-graduation, which is where we have our experiences in the post-graduation courses, and now we are beginning to apply the same model of projects in technology for technologists course. So we have seen that this model works very well, but it's quite complex when I increase the number of disciplines or subject matters. Next question, Gustavo. Next question came from Mario Vasquez and is the following. How is IoT is being used, or how can it be used in the traditional education courses in terms of student skills, both from the side of the professor and the student? So what we have been doing is to include in the other courses that we have, for example, the industrial automation course has a module for innovation and a module of Internet of Things, because we are able to give very simple explanations. For example, let's say we have an animal, a dog, that I'm going to travel and going to be home alone for a month. So I can purchase a food dispenser that every 3 hours will feed the dogs. But perhaps this dog can run away at some point, and I will have 3 months throwing out food for him. The Internet of Things, its function is to be able to increase the precision of the actions that we make. So if I put a collar on the dog that communicates with the food dispenser, then I know the dog is present, so the dispenser will release the dog food. But the dog can be dead. So I can put in his collar a sensor that is going to measure his heartbeat. So this heartbeat shows that he is present and alive, so the dispenser will release the dog food. I can also put a charge, a cell, a battery cell. So if I put 100 or 200 grams, I put to 200 and he only eats 100, there will be a simple machine learning, very generic, that the system alone will perceive that this is happening and will now only release 100 grams of dog food. So the idea is that as we work with these ideas, because today the schools apply this only for devices. So I'm able to turn on a lamp through my cell phone. These are very simple things, but the purpose of Internet of Things is to be able to use this collective intelligence of things. So I have several things which are connected, and through for example, the dispenser is connected, the collar is connected. So the more information I have to make a decision, the better it will be the result. So what we see is that ideally we must include at least one subject matter in each course because the Internet of Things and artificial intelligence in very little time will be the same as electricity. It will be present in everything. And this won't take long because as I have the enabling technologies available, and the cost of sensors and devices will go down. So this application will be ever more present. So we must see how we can use this in the courses, how we can place this in the courses. Okay, Gustavo, any more questions? Can you tell us about examples of IoT with how many sensors have been managed up to now? If you have used 5G, and how can this be applied? Well, some examples. The first example, I'm going to talk about a project that is ongoing now in the classes that are being held now. So, two students make a project. I'm going to highlight one because we receive students from different areas, and one of them is an architect. And this architect puts in his projects commercial buildings, he puts aquariums in the lobby. And he brought an aquarium here to collect from this aquarium the level of oxygen in the water, the temperature, the level of debris, if it has to be cleaned or not, some properties, some
uh, some properties of the water, and he was able to discover a range of temperature and oxygenation and water movement in which he's able to put fresh fish, freshwater fish, and ocean water fish together in the same aquarium. And he's going to put this now as a patent to be able to present these aquariums with this new functionality, which is to have freshwater fish and seawater fish. We have we're able to control 12 different sensors up to now. Another characteristic is here in this school we have a sector which is biomedicine. So we have, for example, almost a hospital here. We have a surgery center, we have a CAT scan, um, ultrasound. We have 78 kinds of hospital equipment. Senai now has a partnership with Nokia and is installing 5G in an area in São Caetano, which is close to us here. And we are going to be connected with them. And the idea is that within this course, we develop a post graduation in the area of connected hospitals because we have two possible situations in the hospital. One would be the hospital connected to the infrastructure, and the other is the patient to be connected. So we are preparing to be able to work in this line of work. And this 5G system from Nokia has been installed some months ago. So we are still studying how we are going to use this resource in a professional scale, because up to now we were only using it for uh, the resources for Raspberry and Arduino, as SP32, for example, that has several shields, several devices already, and that leads the student to have more knowledge in this area in terms of concept and practical. Uh, and whenever they're going to work with a manufacturer, be it in 5G or Wi-Fi or a manufacturer of 5 point that we have here, they're going to receive training focused on the product and the application of the type of company that he is working, but he leaves the course with a more complete overview. So I believe that probably the beginning of next year, we will already have applications, real applications to present within the scope of hospitals, which is one of our specialities here in our school. Well, as has been arranged, we have had 10 minutes of questions. Gustavo and Mirino are going to organize the questions. They're going to be sent to Professor Ricardo, and he will answer via email. Once again, I would like to thank Professor José Ricardo da Silva for his great speech, and we are opening the possibility for knowledge exchange from his speech, be it through a visitation. So please feel free to contact us. I'd like to thank uh, Sintra from El Salvador and Mauro from the Dominican Republic, which are members of the directory. and that follow up these professional education. I would like to thank Alex that translated into English, Georgia translated into Spanish. Thank you very much once again to Jose Ricardo for your contribution. Thank you very much, everyone, all participants. And once again, please place in your agenda on the 29th of April, we will have a meeting at 11 o'clock and we will announce the presentations, the knowledge exchange so that we can learn together and transform the professional education in the Americas so that we have through this education a economic and social transformation for all. Thank you very much. Good work, everyone, and see you next time. Thank you.